Good morning. So today we are going to discuss about how to solve a game, two-person zero-sum game without a saddle point. So let's start with it. So this is the main question we are going to discuss today. They explain how a rectangular game without a saddle point is solved. If a rectangular or two-person zero-sum game does not have a saddle point, the two players cannot use pure strategies. That is, maximin and minimax criterion of optimality cannot be used. Then the best strategies for the players will be mixed strategies or optimal mixed strategies. If the payoff matrix of the two-person game where there is no saddle point is not a 2 by 2, then we have to reduce the size of the matrix by using the rules of dominance, which I am going to explain in the next few slides. Now let us take a example. So this is a game, two-person zero-sum game, and the question is solve the following game. So for solving a game, first we will try to find a saddle point. So for trying to find the saddle point, we first have to encircle the row minimum values of each row within circles like this. Then we will put the highest values of each column within small squares. So here we have row minimas, that is 2, 3, 2, and column maximas 7, 8 and 8. So maximin will be the maximum value of the row minimas, that is 3, and minimax will be minimum values of the column maximums, that is 7. So we have seen that the maximin and minimax are not equal, that is, the game does not have a saddle point. So we have to use the rules of dominance and reduce the size of the matrix. So if we see all the values of row 2, those are 7, 3 and 8 are greater than the corresponding values of row 3, 6 to 7. This means row 3 is dominated by row 2. In other words, we can say that player A will never use strategy 3, because whatever option B takes, A will always gain by adopting strategy 2. So he will never use row 3, that is his strategy 3 or option 3. Hence it can be deleted from the payoff matrix. So now we have a reduced payoff matrix. So our payoff matrix would be now a 2 by 3 matrix from 3 by 3 matrix. So we have 2 rows and 3 columns. We have deleted the row 3. Now again let us see whether this has a saddle point or not. Again we will encircle, find the row minimas, that is 2 and 3, and column maximas, that is 7, 8 and 8, and maximin is 3, minimax is 7. Again we do not have a saddle point. So again we will go for the rules of dominance and try to reduce the size of the matrix. So this is the matrix, and if we see the values of column 3, that is 3 and 8, are more than the values of column 1, that is 2 and 7. This means column 3 is dominated by column 1 and player B will never use that strategy. Hence the column 3 So we can see here column 3 can be deleted from the pair of matrix. This means we have again a reduced matrix. Now it is a 2 by 2 matrix. So now we can use the rules of optimal and mixed strategy. So again we will again try to find out the saddle point. Here we can see that there is no saddle point because maximin and minimax are different. So this is the formula. This is the 2 by 2 matrix where no saddle point is there, and A strategies will be x1 and x2, and B strategies will be y1 and y2. So comparing this matrix with this a11, a12, a21 and a22, we can find the rules of optimal mixed strategy. That is x1, value of x1 is this, x2, y1 and y2. Now in our given matrix, that is this matrix, a11 is 2, a12 is 8, a21 is 7 and a22 is a22 is 3. So these are the values, and we will put the values in these formulas to find out x1 and x2, y1 and y2, and value of the gam, which is given by this formula. So if you put the values in these formulas, x1 will be 3 minus 7 divided by 2 plus 3 minus 8 by 7, which is 2 by 5. Then x2 comes out to be 3 by 5, y1 is half, y2 is half. So we have the values, the optimal mixed strategies, that is x1, x2 for player A and y1 and y2 for player B. Again, by using the formula, the value of the gam, if we calculate this, a11 into a11, 1, 2, 2, 1, 2, 2 in the formula, if we put in the formula, so we get the value of the gam as 5. So now we come to the conclusion of our gam. So optimal solution of the gam is given by optimal strategies for player A is 0, 0, 2 by 5, 3 by 5. Optimal strategies for the player B is 0, 0, half and half, and value of the gam to player A is 5, and it will be minus 5 for player B. So this is how we can find the solution of a gam, 3 by 3 gam, which does not have a saddle point, using the rules of dominance and optimal and mixed strategies. Thank you.